Today we're going to be talking about both organic compounds or organic chemistry as well as nuclear chemistry. We'll start off with Chapter 12, the organic compounds, and we'll continue on from there. The core concept is that the nature of carbon atom allows a great variety of different organic compounds as well as some other inorganic compounds as well. And many of these play a vital role in our living. Organic chemistry concerns itself primarily with the carbon atom, almost always carbon-hydrogen atoms. Okay, inorganic chemistry is the study of all other compounds, and carbon is an essential requirement. Hydrogen is almost always there as well. Sometimes there's other derivatives as well, but primarily carbon and hydrogen. Many other times there will be an oxygen or a nitrogen involved as well. So the majority of the known compounds are organic or carbon-based. And that's because they're just a sheer variety of how many you can have and how they can link together to create a virtually limitless combination. And so chemists are coming up with brand new compounds every single day. Now, the hydrocarbons are the organic compounds that contain only carbon and hydrogen. The very simplest of these is methane, and we've known about that from the molecular formula that we had, the structure and the orientation that we have for these. So this is the very simplest. From this one, you can build it out by exchanging one of these hydrogens for a carbon and then having it linked to another carbon and another carbon. And so you can see how you can just keep building on it in this direction, in this direction, in this direction, and of course in this direction. So, and also you can have double bonds and you can form triple bonds as well. And we'll talk about all of those as we go through this chapter. First of all, let's talk about saturated. Saturated means that every carbon has 4 bonds associated with it. 4 individual single bonds with it, I should emphasize, because this has 4 bonds as well, but this one right here is a double bond. This is called an unsaturated. So when you're hearing the talk about the unsaturated fats and all of that, that means that the carbons in those have double bonds associated with them. So, and then you can also have triple bonds, as we saw before as well, right? So, and you'll notice that there's a name change. This has got 2 carbons, and this is called an ethane. If it's 2 carbons with this double bond, it's an ethene, and with a triple bond here, it's an ethyne with E-T-H-Y-N-E, okay? So, we'll continue on, we'll talk about those. And this is an unbranched one, and it's not in a. It may look like it's in a straight chain, but remember these are all at a 109-degree angle, and so it is actually going to be looking more like this one. In terms of the names, the simplest one is methane. The next one up is ethane. With 3, it is called propane. With 4, it is our friend butane. Then we get up to 5, and it's pentane. 6 is hexane, heptane, octane, nonane, decane. A few of these should be very familiar to you. Octane rating is what we base our gasoline composition on. The hexane is a very common solvent. Butane is in so many of the different lighters. Propane is in what a lot of people grill with this. Methane and ethane are different ones which we burn quite readily. Okay, so that's the naming of them, and so you should. Well, it's not required, but a good general knowledge of chemistry recognizes these type of first 10 names for the different ones. So, and isomers, okay. Isomer, the first one is a straight chain. We would call that an N dash and then what the name is. For N-butane, that means that they're all in a straight chain. If you have them arranged in instead of 3 in a long chain, they have them into a circular format. It's called a cyclo. So you can have cyclopropane, cyclobutane, cyclopentane, cyclohexane, right? You can also have other isomers as well. If you have, instead of having it all in a straight chain, you have one of the ones at the end attaching itself to something in the middle as well. We'll talk about those more later. So, alkenes are hydrocarbons with double carbon bonds. They're called unsaturated. And you can add more hydrogen to form an alkane. So the simplest is ethylene, right? So here's ethane. This is the ethene, as we saw before. Hydrocarbons with the triple bond, they have the YNE, as I mentioned before. And acetylene is the easiest one of those. So you'll notice that the general formula, an alkane, if you have a CnH2n plus 2, it's an ethane. An alkene is a CnH2n. So there's twice as many hydrogens here. That's because the ones on the end, somewhere along the line, are taken off. And so these extra 2 are missing. For an alkene, you're missing 2 more, aren't you? So for every triple bond, it's 2n minus 2 for the hydrogen versus the carbon content. The ring structures, with the ones we saw earlier, were very simple rings. They had only a single covalent bond between each one of them. You can also have double bonds there, and remember when we talked about the resonance structures, things going back and forth between the 2 different ones. And that is one of the simplest ones, is benzene of this structure. And it is oftentimes, instead of represented like this, they represent it as if it were this. Or sometimes, if they only have one of these structures, you have to recognize that it will be going back and forth between the various forms of that. If you have an OH group off of one of these groups, it is called phenol. If you have a CH3 group off of one here, it's called toluene. And if you have 2 of them here, it's called xylene. Okay? And we'll get to more of the nomenclature of how to name these things later on. So, for the petroleum, although it's kind of had a tough stage right now in our time, because so much of our industry depends upon that. So when there is not the demand for petroleum, it means that the industry is essentially shut down. Not a good thing for the state of America. So when it comes out of the ground, it's a mixture of alkanes, cycloalkanes, and some aromatics. And the crude is pumped out of the ground. And what happens is they heat it up. They have steam running through here, and then steam is then condensed. But as it goes in there, this crude oil goes in there, what happens is you have it separated out in different ones. You can have the sludge, or the residue, is going to come out here. This is your asphalt and your tire. The lightest ones are your lubricating oils, okay? Then after that comes your heating oil. Then comes the kerosene, and finally the gasoline. Actually, above the gasoline, there's a few other layers. Your diesel is located in here for your heating oil. Okay, so your diesel is in this intermediate range right here. Your gasoline is a purer form. So this right here, lubricating oil, that can be almost anything. Okay, so the purer it gets, the higher you're going in here. Okay. And so finally, what the gas that comes out of here is your methane and your ethane. Everything else, well, yeah, I guess sometimes you can also get the propane and butane too. But everything beyond that, from the pentane to the hexane and octane and all that comes out here in your gasoline. And so here is, you have the number, your natural gas is 1 to C4. Once you get to pentane, as I mentioned, to C5, you have your petroleum ether gases. Gasoline is C5 to C12. Kerosene, C12 to C15. Diesel fuel is higher yet. Motor and grease are in this level. And your paraffins are much longer. And when you get down to the bottom of it, the sludges are C40. Okay? So the paraffin melts at 55 degrees. So it's not, it is not a liquid. And of course, asphalt is not a liquid either. These in this range are thick liquids. Here are thinner liquids. This is still pretty much a liquid. And then this right here is strictly gas. Now, it's possible to substitute one of those hydrogens for other atoms. For example, you could put a chlorine atom in place of one of those. And if you have 3 of them, that makes chloroform. Okay? The other name for this would be trichloromethane, right? This right here is tetrachloromethane. The common name is carbon tetrachloride, where all of the hydrogens have been replaced by chlorine. You can also replace it with fluorine and chlorine. These are the freons, the materials that we use in our cooling systems as refrigerants. So this would be difluoromethane. And here you have a double bond in there. And so this is with a 1 chlorine substituting for one of those. Instead of having ethane, right, E-T-H-E-N-E, what you have is vinyl chloride. Okay? And this is very important for polymerization reactions. So, the way we name these, we start off with one end, just 1, 2, 3. And then what you do is, if you have, instead of a hydrogen here, you have a chlorine, you would call this 2-chloropropane, right? So this is propane, this is 2-chloropropane. If instead you have a methane group, this would be 2-methylpropane. Here you've got 1, 2, 3, 4, 5, 6 carbons, so that's a hexane. And you've got a fluorine. And what you could do, if you started from this side, you'd be doing 1, 2, 3, wouldn't you? And so it would be 3, 5 difluoro. But you want to have the smallest numbers here as possible. And so you start counting from the side where the functional group is the closest to. So it would be 1, here would be, you start at this one right here. So this would be 2, 4 difluorohexane. Likewise right here, you start counting from this side because the closest one is on this one. So this would be 1 bromo, 3 chlorohexane. Okay? So this one right here, you've got a bromine right here and you've got a chlorine right there. So what that means is you'd start counting here, wouldn't you? Right? So it would be 1 chloro, 2 bromo, and you've got 1, 2, 3, 4 of these. So that would be the butane, right? So it would be 1 chloro, 2 bromo, propane. Now, this methane can also have a hydrogen missing from here and be attached someplace. So we would call this a methyl group. And for ethane, if we had one of these and it was attached somewhere along the carbon chain, it would be called an ethyl group, right? So it gives us some other ways of naming these compounds. So depending upon what the structure is, you can have methyl groups and ethyl groups, as we just saw. And once you get beyond that, you have to name it for the orientation. If it's a straight chain, it's an N or a normal. So that's N-propyl. If instead the bond is to this center one, it's an isopropyl. So isopropanol means that your OH for your alcohol is off this center one. N-butyl, because it's all in a straight chain, and we're going to have to stop there, I guess.